Okay, so let's get started. So the new board from PCBWay has arrived. So let's have a quick look at it and see what's what. There's all of the bare boards. I'm not really interested in those right now. Let's move these out of the way. Let's get the mostly assembled board out and have a look.
And thank you very much to PCBWay for sending me this very nice desk protector mat and also some other Christmas goodies. It's very nice to get this kind of surprise gift from them.
Okay, so let's have a look at the bottom of the board first of all. Looks good. Looks nice and neat and clean. Looks very well put together. Turn it around. Here we are. The version 9.3 APU for the MegaWang, the expansion hardware basically. So we can see here that there are some that are not populated. So for example, this one here is a single, I remember now, it's a single lone 374. So I ordered these ones, but I had these ones to hand, and then these ones are 273, so these ones are all fitting into these larger dip sockets here, and these smaller ones here are 7408s. So I'm going to populate these, and then I will be ready to test the board. I'm also going to electrically test the board before I start assembling, of course. That's always something that you should do. I'm pretty sure that it's fine because it would have already passed PCBWay's electrical test, and PCBWay give me excellent results for the boards that I've ordered from them. You might have also noticed that they also sent me this rather nice little desk protector for my assembling jobs, which was very nice of them. It was a very nice Christmas present to get that kind of thing from them. Let's just do a quick check for no continuity, rather, because we don't want to hear anything from continuity between what's meant to be ground and what's meant to be plus 5 volts. There isn't anything there at all. Right. Right, and then of course if I check between ground and ground, then yes we have. But if we check between ground here and then one of these, there we go. It's probably output enable because that is the 374. There we go. The ground continuity looks fine. Right, no problem here. Okay. The plus 5 volts continuity looks also okay. No problem there, no problem there. Where is it meant to be up here? There we are. See? No problem at all. So I think we can start assembling this without any issue.
And here we are with the board assembled, and it's a daughter board basically, but this is the same user port interface board that was plugged into the backplane, which is now plugged into here. The reason why this is a separate daughter board is that if I change the protocol for the Commodore 64 to user port, which converts user port data through to the 24-bit memory bus here. If I change the protocol, I don't need to change the whole board for the APU. I can just swap out these. Now it's time to test. So here we are with the APU board fully assembled and added to the stack of other boards. So I'm just going to run the demonstration now. I've just uploaded it to the Commodore 64 using ET transfer, and there we go. Now I have to do some debugging with the APU hardware because there was some contention between the
Commodore 64's CPU, and when it was uploading data to the user port, and it was uploading data to the internal APU memory, and it was having some contention which was causing the APU to read spurious values. So this demo doesn't quite do all of the updates that were in the information, because the tree position here, which is a great big multiplexed bank of sprites, is not being sent because there isn't enough time for the Commodore 64 CPU to send that while avoiding contention. So I'm going to have to improve the hardware design where there's going to be a buffer of data from the Commodore 64 user port interface, and it will service that data after it has some spare time during APU execution. This will remove the need for the APU to retry instructions, because the APU will find free slots to upload data that was being sent via the user port interface, the internal interface. So as you can see, the raster bar effects actually work really well. Obviously the multiplex sprite works really well. The blimps up here which move around are actually sprites as well. The sprites in the background, their priority is changed to the foreground, so the clouds and the background here are all tiles. For example, the wall here is actually made up of characters. So the rest of the hardware is actually working really well, and I added some extra scaled sprites as well, just to prove that we've still got the scaled sprites board plugged in and actually working as well. So this demonstration is actually doing now more than what the Amiga was capable of, apart from this tree is not moving here, but that's not too bad. Actually, on the Amiga Shadow of the Beast title screen, I think the Amiga was also using sprites to draw this as well. So if I press fire now, hopefully this will work. It will go into the game, inverted commas, and there we go. The game uses a slightly different screen setup, so actually the trees now that you can see moving around is actually using the character screen which was being used for the Shadow of the Beast logo. So the main player character here is actually the sprites being used in the relative priority for the rest of the screen banks. The blimp here and the other blimp, and there should be a smaller little blimp as well which comes along at some particular point in time. Those are all sprites as well, so you can see that all of the prioritization works, all of the raster split effects works really well. So I'm really pleased with this first version of the APU hardware. I think now I can work on improving the hardware implementation of the bus contention resolution, because the first version just wasn't quite as good as perhaps it really should be. And this will actually allow me to increase the memory throughput, because the Commodore 64 would not have to wait to avoid contention with the APU's internal memory. So I will do that. But yes, I'm very happy with the initial hardware tests. I'm glad that it's all working as pretty much as well as I hoped. So thank you very much for watching these crazy hardware or retro hardware development videos. If you like what you see, then please do remember to like or subscribe or add a comment to the video comment section below. Thank you very much and have a great day wherever you are.